Hello everyone. Assalamu alaikum. I'm Salman Ibn Yunus. In this presentation I will talk about transformers. So first of all we need to know what is a transformer. Relationships in sequential data such as the words of the sentence or even DNA or RNA sequences in genomic data science. It applies mathematical techniques called attention or self-attention which evolves itself, thus it makes it unique. Transformer was first introduced in 2017 paper from Google called Attention is All You Need. It is one of the newest and one of the powerful classes of foundational models invented to date. It is a current state of the art entity model and considered as the evolution of the encoder decoder architecture. So, what are the uses of transformers? Transformers are able to translate text and speech in almost near real time. They are assisting researchers to comprehend the chains of genes in DNA and amino acids in proteins in ways that can speed up drug design. They are also capable of identifying trends and anomalies to prevent fraud, to streamline manufacturing, to make online recommendations, and to improve healthcare. They can also be used to write stories, essays, and poems through applications like ChatGPT. Model architecture of transformer. The transformer mainly follows the encoder decoder model. So what does the encoder do? The encoder takes in our input and outputs a matrix representation of that input. For example, if we take English sentence how are you as input, then the decoder takes in that encoded representation and iteratively generates an output. In our example, the translation sentence is it might be in another language, which an encoder decoder architecture can do. Self-attention mechanism is the core of transformer architecture. It allows the model to weigh the importance of different words in a sequence. Self-attention eliminates the requirement for sequential data processing, which we use in RNNs and LSTMs. Also, it uses multi-headed attention, which focuses on different parts of the input sequence simultaneously, enhancing its understanding of context and relationships. In an encoder workflow, if we explain, the primary function of the encoder is to transport the input tokens into contextualized representations. Unlike the earlier models that process tokens independently, the transformer encoder captures the context of each token with respect to the entire sequence. Let's see some example of transformer models. One of the most popular open source natural processing framework is called BART, which has revolutionized NLP with its unique bidirectional training, therefore allowing the model to have more context-informed predictions about what the word should be. And there is another popular model called Lambda, which is short for Language Model for Dialogue Applications, which is also a transformer model developed by Google, designed particularly for conversational tasks. They generate more natural and contextual relevant responses, enhancing user interaction in various applications. Then we have GPT and ChatGPT, which is the most popular model right now. They use advanced generative models which can produce coherent and contextually relevant text. GPT 1 was the first, and GPT 3 was the most impactful one. These models are great at a wide range of tasks such as content creation, conversation, language translation, etc.